Now I'm going to discuss your paper. So it's been 22nd January, morning shift. I'm going to discuss, right? So it's the like memory-based questions. So have the questions. Question number first. So what's the question number one? Two disks having same moment of inertia. There are two disks, both have a same moment of inertia about their axis. Right, students? Thickness is T1 and T2. They have a same mass density. Mass density is, I can see, student, this is a basic point which you have to just, I can say, highlight. What is the first point? Same moment of inertia. There are two disks, right? Both have a same moment of inertia. Students, ratio of radius is mentioned, R1 by R2. That is what students, 1 by 2. Find T1 by T2. Student, it's very, I can see easy questions, right? You can put this question from category of easy. And one more thing, student, that is, you can say, this questions from 11th class. Chapter is what, student? Rotations only. Because at this point, not only I can give you solution, I'll also convey the points. What is the things which you will get benefit. At this point, it's a primary, I can say, very prime issue to guide those who wanted to study and who wanted selection. Students here will go through the, I can solution. So now, friends, for solution, what I can say. There are two disks. First, you can just draw swim diagram. This is a diagram. You can take this. Let us suppose I'm calling this is disk A. Next, students, I'm calling this is radius. You can take a students here. This is mentioned. You can take R1. This is R2. Beta, what's the? You can take masses over here. You can take student. This is masses is M1. This masses is what M2. Students, here I wanted to find what I1. I can say what is students thickness ratio. So students, first I'll write individually moment of inertia of I can see disk A. Student, this is moment of inertia of B, disk B. So what is students moment of inertia of disk A? This is I A. A you can say, or you can say I1. What is moment of inertia of disk at the I can see this center point? MR square by 2 beta. I'm calling M1 R1 square by 2. Students, here I'll use a formula of mass. That is what they mention. Mass, same mass density also. Students, here I'll use density is what? Mass per unit volume. Beta, I can write mass is equals to density into volume. Mass is what, beta? I can say this is what? Density into volume. Okay, fine. Now here, just we'll go through this because the masses you can use over here. So students, first I'll write I1. What is M1 student? This is rho. And what is the volume beta you can write? This is what? Area into length beta G. So this is rho pi r square into what? Beta. You can see this is the T1 basically, right? Okay. Now beta, this is remains rho. Here you can write pi r square into T1 into what beta? This is what you can say R1 square. This is what remains. You can say beta 2 only. Then beta I1 what you will get? Rho pi. You can see beta this R and R both are dimensions. You can say R1 Q into beta G T1. Okay, beta. Just we'll go through beta. I can see this is a student very high recommendation because you will go for tomorrow. I can say shift number 2. Beta for I can say you will go through just what I'll solve the questions. What's the approach? Just you can learn from here. What's the approach of the question? Beta will help you, right, my dear? Will help you a lot in tomorrow paper. This is what beta you can see two, right? Similarly, beta ji, this is step beta for you. Just I'm writing every questions, right, beta? Like in step. So beta, this is step one, my dear. Right. Now, beta, I can say I'm going to start step two. So beta ji just will go through step two beta. What I'll write to students there is what I2. Similarly, beta, I'll use same formula. So what beta I2 I can write sigma pi beta. This is R2Q into G2 upon beta G2. Students, you know in the question mention beta same moment of inertia. So student, step 1 to finished, right, my dear? This is students, I can say step 3. I'm going to equate moment of inertia I1 is equals to I2. Now students, I1 is what we already found, rho pi R1 Q beta. This is T1 upon T2 into what beta? Rho pi, you can say R2Q into T2 upon 2. Now students, you can say rho pi to cancel beta. We wish to find basically beta what? T1 by T2. So you can write, my dear, T1 by T2 is equals to what beta g? You can say R2 upon R1. Entire beta what? Whole Q. Entire beta what you can say? This is what? Basically whole Q. So beta I can say pi R square, and beta I can, this is R square R square. It's my mistake dear. It's R to the power 4 everywhere. R to the power 4 beta. Beta, in the question mentioned, student, this is R1 by R2, and here is what? R2 by R1. So, students, what you can say, T1 by T2, nothing but 2 to the power 4. So, student, answering it, what answer you can suppose to write? This is what beta? You can say 2 to the power 4. This is 16 beta G. So, what options number B is correct? Options B is correct. Now, students, have a look next questions. Beta, what's the next question, student? If series, literally, beta, it's a high recommendations for those candidates who are going to be a part of tomorrow exam, right, beta? Just we remember this concept. In series RL circuit, voltage students know physics point is not, I can say, platform, just only give the solution. Students also, I'll reveal the short trick or like I can say many easy way to solve the paper in the examination hall. So, student, I can say a series of RL circuit, voltage of I can say uh, voltage of battery that is 10 volt, right? Students, there is what mentioned resistance and inductance are of 10 ohm. Okay, fine. Now, beta, during reading the paper, beta, just I'm giving, I can say, way for those candidates who will write tomorrow exam. Yes, beta, all the best. Literally, correct, beta. I can see beta RL series, right? Beta, first you can just understand this question from which chapter? Beta, this question from EMI, electromagnetic induction, right? Voltage of, I can say beta, there is mentioned 10 volt. So, first, I'll just make a diagram of RL circuit. Student, this is, I'll make, this is what, my dear? It's the RL circuit, right? Yes, now, this is the point which you can keep in your mind for the questions. Beta, this is mentioned beta, this is what? 10 millihenry. Should be punctual, be more attentive beta ji before writing, and I can say final answer of the questions, right? Take once unit as well. Unit is highly important, students. This is a 10 millihenry beta, and this resistance is what mentioned. This is 10 ohm. This is what beta? Potential which is connected. This is 10 volt. So what in the question you can say, beta, first you have to find what's the current at steady state condition. I hope all of you remember it's a very common students question. Either you can connect same questions in RC circuit. These I can say two will act as the same principle, my dear. So step one beta, first at a steady state, what you can say inductor act as a open circuit. What my dear? This is the point I can say major point, culprit of this question, student. At a steady state, inductor behave as a short circuit. So student, simply you can find I. I is nothing but this is V by R. V is what beta? This is 10. 10 beta and R is what? Beta, this is remains same. So what you will get? Current you will get first ampere. Beta, I know what we wish to find. Find energy stored in the inductor. We have to find energy beta, right? So you can see in the step 2, you can just think about what's the energy formula which is stored. Energy is stored in inductor in form of magnetic field beta. What we can say? Half L I S for media. Explain use of semiconductor in galvanometer. Beta, I'll do all the questions. Don't worry, beta. I'll do. Hello, student. I'll do all the question, beta ji. Just stay in the meeting. Sir, which class? Beta, this is from 12th class student. This is from 12th class, my dear. So, beta, I can see for this one, L is mentioned, beta, I is also mentioned. But what's the questions? Energy, I can see, beta, inductor, when current reaches what? 1 upon E times. Current, what was the 1 upon E times, beta. So simply you can write beta this condition. So energy beta what? 1 by 2. L beta mentioned 10 millihenry. 10 into 10 to the power minus 3. What is current beta? Current already mentioned beta ji. 1 upon E times beta. You can write 1 upon E beta whole square. Okay, 11th class beta. Wait, next question beta for you only. Are you faculty at any institute? Yes, beta. I'm working some. But I can't tell students here, right? It's my own platform, beta. It's my own platform, physics point. So, beta, you can take beta. You can take over here 2.71. Students, I can see on Saturday. I'll be live. I'll start concept here. It's a very high recommendation by students. So, student, I'll teach concept as well by Monday, Sunday onwards. Now, students, energy, how beta? This is 10 to the into 10 to the power minus 3 beta, 1 upon E square. E is mentioned for us. Beta can feed the value, right? You will get beta ji. This is 0.67 beta ji microjoule. So, which option correct, my dear? This is what you can see option number C. Option number C, my dear. Uh, okay. Then I can say I am Pandey. What's the shift? May I know your shift, student? Shift one or shift two? Okay. Now, students, a potentiometer null point. Okay. Student, no, this question is yesterday asked here. It's a repeated question. Not exactly this question, student. Oh, shift one. I am Pandey. I'm just solving question of shift one beta. This is the question beta I'm discussing with everyone of shift one students. This question beta already asked yesterday also. This question beta they asked yesterday. I can see shift number two, right? Maybe. So students, same question they asked, but there is a little change in this question. No, beta, it's wrong perception. Don't do Google Sriyansh. Oh, Sriyansh yesterday also came. Yes, Sriyansh also came beta yesterday. No, beta, not 35%. Sriyansh, I can say beta for 11th and 12th, almost percentage like beta is this. Students, Sriyansh 49 or beta 49, let us suppose 11th class. Then beta, you can say 51% of 12th class. Student, this is I can say conditional student. This is the condition only beta, right? Sir, what do you think which person is major asked? Beta, I can say for that condition, it's highly required mechanics. Mechanics be command. Mechanics will help you. I can say 11% also, 12% also. Right, beta? So mechanics too, I can say very more grip. Yes, almost 1 to 3% maximum student differences. Maximum 1 to 3%. So now have a look questions here. What question says? In a potentiometer, null point for two resistance R1 and R2 is at 40 centimeter as shown. Okay, now beta, this is the already mentioned. I can say that this is the first condition. You can take students. I can say Ayan Pandey. This is shift number one student, right? Shift number, I can say it as step one. What says initially we are getting null point over here. What 40 centimeter. I hope all of you remember what is the condition for potentiometer. Students, you can use this basic formula. This is what, my dear, R1 upon R2 is equals to what? Beta, you can say R1 upon R2 is equals to, you can say L1 upon L2. Or beta, I can say R1 upon L1 is equals to what, my dear? R2 upon L2, my dear, right? R1 is what? Beta, we don't know. We used to find R1, R2 basically. But L1 beta known for us. How much? 40. Because you know what is the length of a potentiometer wire? 100 centimeter. So this is the 40. So remaining is what, my dear? 60 only. So beta, you will get finally R1 is what? L1 beta, you can write. This is R1 upon 40 centimeter, my dear, and R2 upon what? 60 centimeter. Right, beta? So you can say this is what? 22 is a 40 and 23 is a 60. So you can write it as the R1 is equals to 2 by 3 R1. Okay, I'll try, student. I'll try, my dear, to also convey basic points in Hindi as well. But Hindi is tough, student, because I'm from Bangalore. Now R1 beta 2 by 3 R1, right? Now, with this is the case one. Step one beta, which I explained. What is step two beta Z? That is, it's not tough question, student. It's not tough questions. You can do very easily. But in step two, what they mention, beta, have a look. I can say parallel to R2. They what connected 16 ohm students. Again, beta, you can just make one more diagram. Student, you can make one more diagram, right? Okay. Now, student, this is beta. I can say potential. They didn't mention. I can. There is not a required thing. Now, student, again, you can say this is what galvanometer. This is a galvanometer, my dear. This is you can say. What's the beta? This deflection point, my dear. This is what mentioned 50 centimeter. So you can say L2 is also 50 centimeter. This is R1 beta. This is what, my dear, R2. Students, this is R2, and there is what, according to question, they connected another, I can say resistance, which is what, 16 ohm. Students, now, beta just will just beta you can apply here. You can apply main beta G. This is what both are in parallel, right, beta G? So what you can say R1 upon 50, my dear. Right. This is what the students R1 upon 50 because using same formula beta R1 upon L1 because what R2 upon L2, right? Yes, beta. Good, 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 good. It's easy question. Very good, beta ji. I can see beta R2 is what? Just beta, just two simple. I can say calculation 16 into R2 upper beta G 16 plus R2 upper beta. This is what 50. You can say cancel each other. So finally, beta, you can write this is R1 is equals to 16 times of R2 upon beta 16 plus R2. R1 beta you can use from here. R1 is what? 2 by 3 R2. So we can say, beta, this is 2 by 3 R2 is equals to 16 R2, my dear, upon beta what? 16 plus R2. Okay. Now, students, you can see this R2 cancel with as just 2 cross multiply. Students, I'm calculating finally over here. This is step 3. Okay. Now, beta, this is what students, you can say 2 by 3 is equals to 16 upon beta 16 plus R2, just 2 beta cross multiply 32 32 plus 2R2 is equals to 48 beta. Right. So with that, finally we will get twice of R2 beta 48 minus this beta 16 only na. So student, you will get R2 is equals to 8 ohm. R2 is equals to 8 student. Then you can feed value over here. So what beta R1 will get 16 by 3. Hence student option number C is correct. Hence beta option number C is correct. Now students just move next. What's the question, student? In don't be a swarm beta, you can leave. Don't be a swarm, you can leave beta. Please, you can leave beta. Don't be a swarm. In the given situations, force at a center on 1 kilogram mass is F1. Okay. Now, if 4m and 3m is interchanged, then force is F2. Students, F1 by F2 is what? I can see 2 upon alpha. Find alpha. I can see Shreyans beta. Shreyans, I'll help you. Shreyans beta, now I'm giving you one more information. Students, by Sunday, beta physics point online. I'll start tuitions online beta. 4th February beta, I'll start online class. I can say for JEE main candidate or 11th class student Shreyans, because yesterday you said due to this beta I decided every queries you can post here only student, that is b.sarma9219 at the rate of what gmail.com, right beta. Shreyans, again, I'm repeating, student. I'll help you in physics. Because of you or many students, I can see message me different social media. So due to this, student, I decided, right? Due to this, student, I decided by Sunday I'll become. So tomorrow physics class will start. No, beta, I'll start at class Monday to Friday. Beta, I'll be occupied, right? Because I'm working somewhere at some institute in Bangalore. It's a premium institute student. So what I can say, Sunday, promise beta, Shreyans. Sunday beta, yeah, flute beta already. I can say. Mansi. Mansi beta already fluid beta already I students I can say uploaded beta. For fluid beta statics I uploaded fluid statics lecture 1, lecture 2, lecture 3, lecture 4, lecture 5, lecture 6. Next beta lecture 8 I'll upload very soon. I'm getting little students I can say. Sunday student, I'll start Syrians on Sunday. Student, I'll start beta Syrians on Sunday. Just join every day live classes. Sunday beta, I'll start your classes online, and then I'll continue classes on a regular basis. Maybe in the night student, right beta? In the night student, I'll start. Sunday, I'll take your first class. First class, I'll start by gravitation. It's an easy topic. Then student, I'll start gravitation. Then 11th class chapter I'll do beta, Sriyansh, because major queries I'm getting from 11th class. Beta by tomorrow I'll start beta class soon around 10:30, right beta? Because in evening time beta Mansi I'm getting classes beta it's a tough network issue beta. So by tomorrow I'll do beta. By tomorrow I'll do beta start classes around 10:30 or 10 o'clock. Now, bacha, have a look. Any queries? Just place your query. Shreyans, you can note down, bacha. B for Bombay. B dot Sharma. Sharma. Sharma 9219 at the rate of gmail.com. Right, beta? Just you can post your queries over here. Whatever you have a queries, I'll be see and back to you. Yes, Shreyans, on YouTube, I'll teach you. Uh, Now, students, have a look. This question already I discussed. Right, beta? This question discussed. Now, have a look this question, beta. This question, Shreyans from 11th class, gravitation. Student, this question, students from 11th class, beta, right? This is what gravitation. It's literally easy question, student. I can see what's the question, student. There are four masses, M, 2M, 3M, 4M. So I can say there is 1 kilogram. So first we have to find F net due to these all masses. Then beta, I can say for because everyone know in gravitation only we have what attractive force. What is student? Only attractive force. Okay, so beta, I can say this is a force over here. So what I can write is let us suppose I'm calling this is like beta. This is A, B, C, D, and this is OD. So I'm calling beta. This is I can say step one beta force at OD. Beta, how much? This is, you can say, formula is what? For gravitational field formula? For force formula, what is force formula, students? For point mass? G M1 M2 by R square. Right, my dear? Okay. So, beta, this is what you can see G 4M beta. You can write G into 4M beta. R everywhere remains same. You can take this is R only. Right? So, beta, what we can say? R square. Then, beta, I can say for this year 2 and 3. So beta, this force is what beta? I can see in this direction beta. You know, this is attractive forces. Gravitation force is independent on medium beta. So you can write beta this force is this is a force. You can say OB. Force beta G. You can say OB. This is what? 2 G M by what beta G? This is R square. Right, my dear? Okay. Then beta, what you can say? Again, student, you can find over here. So you can say force due to OA. What beta ji? I'm calling force due to OA. What beta? G into beta M upon beta ji R square. Then beta you can find over here force on you can OC. How much beta ji? This is 3 GM by R square. Now students, because this is the 4 beta, this is what you can say 4 GM by R square. This is what 2 GM by R square. Student will get net beta force this side. Right, beta ji? We can make beta one more diagram. But no, because physics one not giving solution only. I'm trying to convey a concept as well. So beta net force will get this direction. Beta what? 4 minus 2 beta. This is what remains 2 G M by beta. What we can say? R square. Beta, I can see for this case is this is what beta. You can just go through. This is 1 beta. This is what? 2. So you can see beta 2 minus 1. Beta, what will get? 3 minus 1 beta 2 only. You will get net force in this direction beta. In fact, these two are 90-degree here. These two are beta what you can say? This is 90-degree. Right beta? So I can say both are remain same. 2 GM by beta G R square. Next beta 2 GM by R square. Now students, hello students, both are at 90 degree beta. Then I hope all of you remember to add two vectors quantity. What's angle? This is what? 90-degree beta, right? Then beta, we can apply formula. Just kidding. This is what? Beta, directions, you can find direction. This is what? You can say F1. So F1 beta, how much? A square. We can apply beta formula. A square plus B square plus 2AB cos theta beta G, right? So you can say over here F net, or you can say F1 beta G. What will get? A square means 2 to the 4. Gm by R square. 4 Gm by R square. 4 for beta, what we can say? This is 8 G M by what beta G R square. You can write 2 root 2 what beta Gm by R square. Beta, we got this is F1. I can see initial arrangement of the questions. Now, students, have a look next. Students, here I'll discuss according to question what says step 1 beta, this is finished. Now, student, this is step 2, I can say. What says student? No, there is no change in M and 3M. What the change beta? Ji? What's the change? You can say 4M and 3M beta. 4M, 3M, they what? They'll do beta what? Interchange each other. Right? So you will say this side 3M, this side beta, what you can say 4M. Now, students, listen me carefully. It's a 11th class question, students. Serious. So now, beta, this is, you can say 3M, my dear. This is a 4M. Now, beta, this is M, and this is what beta is 2M. I can say beta G for this condition. We'll go through beta solution of the questions. Right. So, what you can say, bacha, this is 1 kilogram. This is 1 kilogram. Beta, this is again beta attractive. Beta, again also same thing here. This is A, B, C, and D beta. This is center point O only. Beta, this force what we can say? 4 Gm by R square beta. This is what? Gm by R square. So beta, I'll get net force along OC. What, my dear? Net force beta, what will get along OC? Beta, how much here? Tell me. Net force beta along OC. I'm repeating, beta. This is 4 Gm by R square. Beta, this is in this direction, my dear. And this is what, my dear, this directions. Both are opposite. So I'll subtract beta. So 4 minus 1. What will get, bacha ji? 3 Gm by R square. Beta, everywhere R means same. Square side A. Now, students, again, you can say this is what? 3 Gm by R square. And this is what? 2 Gm by R square. So 3 minus 2 beta, what will? 3 Gm by R square, dear, in this direction. 2 Gm by R square, my dear, in this direction. So 3 minus 2 beta. What I can say? This is 1 only. Now, beta, I can say force due to OD is what, my dear? 2 Gm by R square. Now, students, I can say, Bachaji, this is the condition here. These two forces, what beta? Again, you can say 90-degree. So, beta, if these two are 90 degree, because this is one in this direction, my dear, and one what you can say, again, not this is wrong, my Mansi beta. This is remains in this direction, beta G. Now, students, you can say these two are what beta? Again, the 90-degree. Mansi beta, Mansi, in which class you are? Mansi beta, in which class you are? Beta, this is a 90-degree, my dear. So again, you can say beta the same thing. A square plus B square plus 2AB cos theta beta. So you can say this is what F2 will get. How much? Beta, you can take student 3 Gm by R square, common student. Oh, very good, Mansi. I'm very happy to see you, beta. Very happy to see you. 3 3 is a beta, what we can say? 9. Beta 2 2 is a beta, what we can say? 4. Right, my dear? Okay. So beta here, beta, what we'll get? This is beta 3 Gm by R square. And beta, this is 4 Gm by R square. So what will get, beta? This is 2 to the 4. This is the 4 minus 1, 3, and 3 minus 2, 1. This is 1, my dear, only, right? So 3 3 is the 9 beta plus 1 only. So what will get? F2 beta, this is Gm by R square. This is root of 10 beta. Let's take ratio of these two beta. Step 3. Step 3 beta, you can just take ratio. Beta what? You can say F1 by F2. Beta what will get F2 here? This is 2 root 2 upon beta. This is what? Root of 10. So beta finally we'll get f1 by f2 is what, bacha ji? This is what? Tell me. 2 upon root 5. So beta they mentioned here 2 upon what? Root of alpha. They are asking alpha. So alpha is what? 5 only. Very good. Yeah, someone already answered this question. Very good, bacha. Very good, beta ji. Now we are just have a look at our next question. So what's the no? This is the question, students. I can see those will go for tomorrow exam. Students, it's I can see very strong recommendations for those candidates will go tomorrow exam. Please, please, please be remember this question. Students, be remember this question because we'll get this kind of questions here. Now, students, I can say, bacha ji, what you can do. Thermal conductivity, students. No, here I'll give the formula here only, right, for solution. What is, students? This is dq by dt. As I said, physics point, not only making solution, not at all, right? I'm here just help to each and every candidate who want to pursue IIT. Then beta, this is dt by dx. Beta, this is what beta? Anyone tell me, please, from all of you? This is known as, my dear, temperature gradient. What beta is the temperature gradient here? But here we wish to find K. K is what? Thermal conductivity. Beta dq by dt. What you can write here? This is what? Joule per second beta. You can write what? Beta area unit what you can write? This is meter square. What is the temperature gradient unit, beta? This is what you can say Kelvin per meter. You can say cancel beta. This is beta will get K. So K beta what you can write? What meter Kelvin? Students, I can say they ask multiple times these questions. So we remember here. We remember by tomorrow. Tomorrow we'll get a student. Those will go to write exam. We remember here. I can say learn one gate for free. What a student? Everywhere. I can just tell you here, Vicha. Everywhere students in the market. We are looking like in the mall and all. Buy one get one free. Students, I'm telling you in physics. In physics beta learn one beta ji get four free. You can see yeah, it's a very amazing beta. It's a very common thing beta. Yes, I'm looking here. Always try to just simplify the physics beta. Easy for everyone. Now, beta, I hope all of you remember pressure is what? Force per unit area. So, what you can write, beta? Newton per meter square. Beta, just remember pressure. Just remember pressure, right, beta? Students, here I can say for pressure vector G, you can just compare stress. Stress is what beta? Again, unit is I'm calling bacha Newton per meter square. Students, you can say Young's modulus. This is what Newton per meter square. Beta, you can say this is what bulk modulus beta. This is what you can say Newton per meter square, right? So these are beta. Just if you remember, I can say pressure. Then you will answer these all questions. So this is a way to just remember and learn physics easily, student. How many questions only are? This question I'm discussing basically beta. Right, this is beta. I can say unit of we can get from here beta. What is thermal conductivity? Is I can say beta there is one recommendation for everyone. But I know JE asked beta this is the multiple time. Students, JE asked this thing beta multiple time. That is what? Students, I can say student this is what? Surface tension and beta spring constant. Beta, rarely they will ask spring constant, right? Because spring constant usually we are calling in like beta the NLM. Beta same thing we are calling in students. I can say next concept. That is what you can do here. You can say this is also known as what beta the force constant. Right. So what is the unit of surface tension? Same unit what you can see spring constant or force constant beta G. So this is what you can say surface tension is defined force per unit length. Right beta? This is what defined force per unit length. So force beta what you can write Newton per meter. Newton you can write here this is kilogram meter s to the power minus 2 beta meter cancel here. So you can write my dear this is what kilogram s to the power minus 2. So finally, what answer is supposed to write? M1 beta g t minus 2. Next beta Boltzmann constant. What is the Boltzmann constant here? I can say beta for Boltzmann constant. Just be remember everyone. Be remember students for Boltzmann constant. This is you can use beta. I can say energy from KTG. 11th class student. This question dedicated only for 11th class, my dear. So you can say U is equals to half of KT. What a student? U is equals to half of KT. Then beta, we used to find K. K is what? You can say Boltzmann constant. U is what beta? Energy. So energy unit what we can say joule only. So what? You can say beta joule per Kelvin. This is what K bacha ji. So from this you can calculate further, you will get answer any of the option. It's a bit I can say math question. I can see column one and column two. So it's not easy, but it's a high recommendation for everyone. We remember, we revise this thing beta for tomorrow. Now, students, let's have a look next this question. I can say, student, this is a question from class notes. I can say it's a very common question. It's a too much standard questions, right? This question from 12th class electrostatics, my dear. What is students? 12th class from what? Electrostatics. Students, for this condition, just make a video. For solution of this question, student, you have to just gently draw a video with, I can say, with a dedication. Now, beta, this is I can say mass particle. Mass is m, charge q. Particle is what students you can say making angle theta from horizontal. I can say this is a basically simple pendulum idea, right? Now, due to mass student, what you can see gravity acting on this pendulum ball at what mg. Student, they mention this is what I can see there applied electric field in what horizontal right directions. Now, bacha, very good yaar, very good Mansi. Mansi, very good beta. Your performance literally in 10th class, super beta ji. Now, beta, this is what? E. So, beta, you can write over here, beta. You can say, Mansi, beta, just I said my email ID, right? You can just be connect over there, beta. You will get any doubt in for JEE preparation. I'll help you, bacha. This is students, you can say force which is what acting on the wall because here students you can use the result of I can say electric field defined force per unit charge. So F is equals to QE. Students, you know in this question what we used to find? We used to find a student that is what I can say tension. That is what tension. Just Mansi just mentioned timing of live session, right, student? So that I can easily recognize to you. Student, they both are at 90 degree. Students, both are at what? 90 degree. Students, if both are at 90 degree, yeah, then I can see all of you remember summation of vectors. How can we do? A square plus B square plus 2AB cos theta beta. Cos 90 0. No beta. Due to these two forces, B you will get net resultant force in this direction, and which is what a positive tension. So simply can write beta. Tension is equals to what, my dear? It's a very easy question here. Mg square plus what, my dear? This is Q square. Okay, now students have a look next question. It's literally very easy questions. Students, this question here. This question will take time there. It's a very good questions. I can say from really beta this question is dedicated kind of advanced question beta. It's a good questions here. What's the questions dedicate? I can say detector D moves beta. This is the point of detector. Point A moves from what A to B. Observes. Beta what? Observe the frequencies are I can say differing by what 10 hertz. Means I can say beta they mentioned already in this question what is the things data you have to find over here in solutions. So they mentions this is frequency of FA minus FB, which is what 10 hertz. So we have to find FA and FB. What is frequency of FA and beta what FB bacha. Now students you can say this is point A, this is point B. Student, this is a basically source. Listen carefully here. Don't be a spam bacha. This is beta. I can say point O. Student, for this condition, you can say there is one more information in this question, student. What's the information in the questions? This is speed of detector. What beta? Speed of detector is what beta? This is 35 times less than. So it can write beta. This is what? Less than speed of sound. So beta, just I'm calling this is what velocity of detector, which is equals to beta V naught. V by 35. Students, this is a basically source point. So what you can say, if this is a source point, so basically students, you are getting frequencies from here only, right? So student, we have to first find what is this angle, because detector motion in this direction. If detector motion in this direction, student, then what you can say, detector is what basically decreasing the what distance between source and detector beta. So here we have to find this angle is what basically. Let us suppose it's a alpha. Alpha is what beta? Mansi, tell beta. Tan alpha is what? Perpendicular upon base only. So students, here from this diagram here, you can write this is what, my dear? Tan alpha is what? This is 120 by 160. This is nothing but you can see beta 3 by 4. So alpha beta how much? This is 37 degree no beta. Yes. Alpha is beta what we'll get? This is the 37 degree beta. Alpha beta what we will get? This is 37 degree. Now students, I'm writing expression of frequencies of A only, right? So beta for frequencies here, I'll use over here frequencies of A beta. This is, I can say student, this is step 1. This is step 2 beta. So first I'll write frequencies. No beta, this you can say this is what detector should beta I'm just calling this is the V naught. So you can see over here one velocity component of detector is what decreasing the velocity of basically you can say sound source. Right, beta? So here we can apply relative concept, Bachaji. So what is the velocity of sound? This is V only. This is what, my dear? V only. But I can write frequencies of A. This is, but I know if they are in different direction. If they are in what? Different directions. So what is the relative velocity? Simply here, we can add only. So FA beta, you can write over here. This is V plus what? V naught beta G cos alpha. Just take component of this beta. V naught cos alpha upon beta what we can say? V. And what is the frequency of source? This is F naught only. Right. Similarly, students, you can write because now finally, let us suppose your detector finally arrived over here. So this is what beta, you can say V naught. Students, for this condition, you can tell my dear, this angle is what? Beta. This is what beta. From this diagram, again we can find tan beta is what? 120 by 90. So students, you can say this is the tan beta. This is 120 by 90 beta. How much here? This is 4 by 3. This implies, students, you can say beta is what? 53 degree. Now, Vichaji, you can say for this condition beta, this is the beta. So no, because this is the velocity of source over here only, or you can say sound. So again, in beta, I can apply same thing. One component of I can say V naught. This is what students beta. I can say from what alternate angle. So now students, this is what component? You can say V naught. What was the cos beta. For getting frequencies of V particle, beta what? Again we can apply a relative velocity. Both are in same direction. So then what you can do? Subtraction only beta. Then you can write over here. This is what, my dear, FV is equals to V minus beta. Tell me beta. For V bacha, V minus this is V cos beta. V minus V cos beta upon beta. This is what remains V into what beta? You can say F naught only. Now, what's in the questions? Because step 2 I explained, but step 1 beta. Fa minus Fe is what means 10 her. Simple, just finish beta. This just two subtraction. So you can write beta Fa. Fa is what you can say V plus V naught cos alpha upon V into beta G, what you can say frequency here minus beta. This you can write V minus V cos beta upon V into beta V naught here. You can see sometimes it's cancelling each other. What we have remaining which are the what we have remaining beta. You can see this is 10 is equals to V naught beta. This is and minus minus plus beta. V cancel. V naught cos alpha plus beta V naught cos beta upon beta G V only. Now students what? You can take V naught common. Then you can say 10 beta. V naught by V. This is cos alpha plus cos beta. Cos alpha beta. This is what? Cos beta. V naught by V we can find from here, Bacha. Because what's the relation? We have V naught is equals to V by 35. So you can say V naught by V, you can write, my dear, 1 by 35. Right? You can beta feet over there. So this is 10 beta Z. This is 1 by 35. Cos alpha beta, how much? Mansi beta? Cos alpha? Cos alpha beta Z? Hmm. This is beta. 4 by 3 na beta? 53 degree. So this is what? You can see beta 3 by 5. This is alpha beta. This is 37. Beta 4 by 5, you can say. Then beta g, what you can say? 3 by 5. So we can write beta 10 into 10 is equals to what, my dear? 1 by 35 beta. 7 by 5 beta. Right. So beta, what is the things here? We'll get beta into F naught. You can write over here. Then bacha, finally you can just solve. We'll get answer bacha. How much coming answer here? Mansi beta 7 5 to 35. 250 beta. This is what? Sriyan's beta. This is what? 250 hertz. This is what we are. Beta, I can see 250. It's I can see beta. Sir, this is one of yes, beta. Quite difficult. Correct, Mansi beta. It's a lengthy question, beta. Ji. Yes, I can see beta. Yesterday I solved many questions of JEE mean, and beta today again already I solved 4 to 5 6 questions. So it's a beta quite difficult question, beta. I can see beta Doppler effect also not a part of I can see beta mains, right? Doppler effect beta part of I can see they erase here last year 2024 only. Mansi beta, have a look next question, students. So what beta next questions? Disk beta, this is there are two disks. Mass M1 is mentioned that is 5 kilogram and radius R1 is what 10 centimeters, students, right? And beta disk 2 M2 is what you can say this is 10 kilogram, radius beta what 50 centimeter are arranged and shown in the figure. Find moment of inertia. I can say beta find moment of inertia tangent beta about this tangent here, right? I can see it's a very common students from class numerical only. Beta, I hope all of you remember here this formula. I'll say little theory about this. No beta, just first you will draw axis of like say this beta from diameter, and this is what beta tangent point. I hope all of you remember moment of inertia for a disk about diameter. But how much? This is mr square by 4. Then beta, we can apply once. This is beta r only. So what is moment of inertia beta? I can see this is, let us suppose it's I1. What my dear? This is m r square means you can write beta m1 r1 square by 4 plus beta. This is m1 into beta r1 square, right? Similarly, beta, you can write my dear for what? This is students again tangent. So we can write I2. This is what my dear M2. I'm not repeating same thing. M2 beta. This is you can say R2 square by 4 plus M2 beta. This is what R2 square. Simple beta. They're asking what is the net moment of inertia. Simple add students. So I you can write this is what I1 plus I2 my dear, right? I1 beta, this is, you can write my dear, this is M1 R1 square upon beta G 4 plus student M1 beta G R1 square plus beta plus you can say M M2 into what beta R2 square by 4 plus M2 beta G R2 square. Simply bacha, the speed entire value are mentioned. This is M1 is 5 kilogram. R1 beta how much? You can say zero point 0.1 whole square means 0.01 beta G. Upon beta 4 plus M1 beta what you can say? This is 5 into beta again you can say 0.01 plus beta. This is M2 which is 10 kilogram and R2 beta G this is 0.25 whole square means 0.25 upon beta G 4 plus M2 beta this is 10 kilogram and beta you can say zero point 0.5 whole square. Right. Finally, beta, we can solve here. You will get how much? This is 3.1875, which is, I can say, approximately equals to 51 by 16 kilogram meter square. Hence, option B is correct. Hence, option B is correct. Now, Betaji, have a look. Students, Mansi, I never care this kind of a spam messages, beta, right? Let it, beta, let it be. Let it be. Beta. I'm here just helping for each and everyone, right, beta? Let it be. Mansi, beta, be positive only. Life will always help you if I can see you with positive attitude. Now, what's the question? Adiabatic process, the temperature reduces to 1 by 4 and volume increases to 8 times. So find adiabatic constant of gas. Student, I can say Mansi because now beta just I'm looking you on my channel. Student, you can go back, right? You can go beta and watch. Recently, students, I uploaded PYQs J2025 beta, right, Mansi? There I wrote by proof, you can go and visit. Mansi beta, I wrote over there, there are two formula for adiabatic. One I can say TV relation and one beta I can say PT relation. I said the students 100% evaluate. Students evaluate 100% and literally beta, I can say, yes, student Sriyan. Sriyan, still you are available. Very good, Sriyan. Sriyan and Mansi, both of you literally very good candidate beta. Shreyans and Mansi, literally, both of you, very good candidate here. I saw many candidate, I can say on live session, but both of you literally very good, with a very good attitude, bacha. I can say very disciplined, beta, both of you. I'm proud on you, yaar, both of you, how your parents grown up. Now, students, just look at next questions here. So, beta, no, I said, beta, I can say Mansi and Shreyans, you can go and watch my channel, 2025. I wrote, you will get definitely this question. It's a high recommendation. Manish, not Mansi. Manish, okay, fine, Shreyans. I'll care, beta. Now, beta, just we'll go through here. So, what's the beta TV relation here? This is beta. I can say it's a very superb result. I can tell those candidates will be a part of tomorrow exam. We remember students. We remember students this result here. So, beta from adiabatic, it's a hero formula beta. This is what you can say T. Uh, T beta, this is T into V to the power gamma minus 1 is equals to this is what beta I can say constant, right? So beta I can use here. This is what T1 V1 to the power gamma minus 1 beta T2 V to the power gamma minus 1 beta. T1 is what beta? What we used to find? T1 you can take beta. This is initial T not only. V1 beta party you can take beta V not only to the power gamma minus 1 is equals to beta. Next T2 beta. What I can see T2 adiabatic process temperature reduces to 1 by 4 beta. You can take my dear. This is initial what I have taken T naught. So finally, students, you can write this is T naught by 4. This is what beta? You can see volume increases to 8 times beta. V naught into what? You can say gamma minus 1. T naught beta cancel. Right. Then beta what you can say, this is beta z. You will go through 4 is equals to this is 8 beta. Forget here. 8 times of V naught upon V naught to the power beta gamma minus 1. Right here. No, no, beta. I can say J little here. So we will get little J problem beta. Right. Beta, you can see this is cancel beta. Ji. You can do Mansi beta. This is the basic mathematics here. 2 to the power beta, what Shreyans? 2 square beta. Ji. Then beta, you can say 2 to the power 3. 2 3 is the 8 beta. Into what beta? You can say gamma minus 1. Mansi beta, I can say Shreyans beta. All of you know basics. A beta, I have the same quantity. Then same beta. We can what equate. Sir, here most of the students. English student, I don't know which English literally I'm little slow students. Beta we can equate here. Literally you correct beta Srians. 2 is equals to this is 3 gamma minus 3 beta g. What we can see? This is what 5. 5 by 3 beta, which is what gamma. Any option is there beta g? Yes, option C, Srians. This is the answer beta, answer of this question. Now, student, just you lucky here, luckily found my channel. Student literally will enjoy physics. You have a like little fair Syrians, little bit. Just join my live session classes of theory classes, normal classes. You will enjoy it. Definitely, it's my open promise to everyone. Those who present in live session. Student, there are six RGs. This question, students, I can say from 12th class electrostatic students. What if six charges plus q and minus q are present at a circle of radius r, centered origin as shown in the figure? Electric field we have to find beta. At what I can say at origin. Now beta, be simple here. What I can say? Beta, electric field. This is the charges and this is charges beta. Equal in magnitude. So what you can say? Beta, this is what? Cancelling each other. So no need to worry about this. Then beta, this is the positive charges. So beta, due to this beta, what you can say? Electric field beta in this direction no? Beta electric field to point charge beta stands I'm telling beta little theory. This is q by charge, this is 1 coulomb charges. So this is the what direction of electric field to point charge. So beta due to this what you can see beta, this is the direction. I can say this is a negative charge. No, beta. What is source of? Students, you can cancel out. Yes, yes, yes. Correct, 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 beta. Oh, Manish Chaudhary, your name, beta. Okay, fine, fine. Usually, I was calling previously Manish Mansi, no, beta. Manish only. Manish beta, what I say, Manish beta, you can say this is beta positive, this direction. Beta, you can just go through here. What is the short trick? Beta, electric field lines always originate from beta, I can say source of light. You can just remember here. It's a physics point. I'm giving you short trick only. Beta, you can say positive charge act as a source of light. Positive charge act as a source of light. Right. Negative charge students, you can treat beta. This I'm telling these all three, I can say for stance because you are in 11th class beta. You can easily understand what I'm giving you, what I'm telling you. Now beta, this is what you can see, my dear. It's a sink of light. This is what, my dear, sink of light. Okay. Now what see, you can see beta these two charges will in same direction. Beta because this is again beta negative charges in this direction due to these charges again in same direction. So my dear, you can see what's the angle between this? This is 60 beta. You can say 60 or 60, 60, 60. So this is when you can make a diagram here finally. This is the diagram beta Z. We will get it here. Right now, what's the angle beta? This angle is mentioned for us how much? 60 degree. Simply our R is remain same. Then beta what is the net force you will get? Chil bacha party? Can you say here? This is your kq by r square. This is again kq by r square beta. So what you will get? You will get, my dear, this is 2kq by r square. Simply beta, I used Mani's formula electric field to point charge. K Q by R square beta. I'm writing side formula side thing here so that you can understand the classes which are. This is what, my dear, 2kq by r square. Now, Bachaji, no, these two are belongs to the what? Electric field quantity belongs to vector. So, student, what we can apply net electric field here. So, what is net electric field, my dear? Tell me, everyone. A square means what, beta? You can say 2kq square whole square plus beta g 2kq r square whole square plus beta 2 into beta g. You can say 2 into 2 beta. Again, you can say kq square by r square and cos 60 beta 1 by 2. You can see beta these two things everywhere kq by r square. So student, you can take it out. What student, you can take kq by r square. Then beta what we can say 2 to the 4 beta Shyams Manish 2 to the 4 beta z plus beta again here 2 to the 4 only 4 8 plus beta how much will say 12 beta. This is what you can say 2 root 3 kq by r square, my dear. Then students, what you can say 2 root 3 and k bacha you can just answer in terms of beta just replace bacha. You can student k is equals to 1 by 4 pi epsilon, my dear. So this is what you can say 4 pi epsilon naught bacha. This is remains q. This is r square. You can say bacha this is 2 to the 4. So what you can respond student answer right correctly root 3q by 2 pi epsilon naught r square. So what's the answer, student? What's the answer? Yes, option number. Yes, yes, yes. More thing, beta. What is the net electric field due to this beta g? Because answer they mention in form of directions. So this is what beta. You will take origin point as a center point as a origin. So right is beta. What we can say? Second hoga. No beta. Answer is first beta. First option. Option first. Maybe beta in your shift beta option change because these are the this is student I can memory based questions. So there is a probability left right students, right? But against the concept remains a beta. Question I'm trying to just take some needful data from students only, bacha. So I can say beta for my solutions according to this bacha, what is answer is what? Minus beta g. There are also minus I care, but answer beta meet like this beta only. So option first is the correct answer beta. Okay, now students have a look next here. What's the next question? I can see an alpha particle with kinetic energy. How much, Victor? 7.9 milli electron volt. Oh, I can say Manish and beta Shreyans, right? This question, beta, in the classroom, you can't imagine. During class, I said multiple times. Beta, be remember, student, I can say this is students basically concept. There are three cases, student. I can say, beta, for closest approach, students for closest approach, there are three. Yes, 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 yes. Manish, correct, 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 beta ji. I can say, beta, this is concept of distance of closest approach. This is what, my dear? Distance of closest approach, right? So, beta ji, this is the case one here. What they asked. Beta, what I can say, this is case one only. So, simple beta, I can say what particle has a, you can just make diagram detail here. Because this is what alpha particle means what you can say helium nucleus. Particle